I want to start off slightly positively because, as you might expect, this talk can get a little negative at times. So first off, software is pretty amazing. If I think about my lifetime and my experiences with software, it has done nothing but improve. The first time I had a computer was in the early 1990s. And since then, I would say things have moved along. It was slow, it was simple. The internet was measured in bytes, which is a phrase we don't use much anymore when it comes to speeds. And websites have also gotten a lot more complicated. Websites used to be textual. A lot of them looked like websites you probably saw in college or high school. White backgrounds, black text, very simple. Now there are multiple services, complicated security and auth layers, multi-regional deployments. So what's pretty easy to expect when I say software is amazing is that so are our bugs. As our software evolves, so do its failure modes. They're going to get more hard. They're going to become related to multi-regional issues, auth issues, security issues, maybe even relationships you have with services you don't even own. So I start to wonder occasionally if maybe the whole computer thing might have been a mistake. And then I realized I went too far. But I kind of miss the good old days. You know, we had floppy disks that were floppy. We had save buttons that saved something locally. And I didn't have to worry about the 3 other things I use that I don't control. But at a certain level, we have to accept that we're going to have bugs. Part of writing software is that we're going to make mistakes. But what if instead of seeing these as a negative thing, we see them as opportunities, individual moments in our development cycle that we can use to improve our processes, improve ourselves, and deliver a better product to customers. So before I go further, I just wanted to introduce myself slightly. My name's Chris. I work at Google. I'm based out of Seattle, Washington. And I've worked in a variety of things, ranging from compilers and IDEs, cloud services, to what I do now. I work on Python client libraries for Google Cloud. This talk is really an opportunity for me to share some of the learnings I've had along the way. If you look at the screen, you'll see a bug. Literal and in the software meaning. As far as I know, this is the first ever post-mortem with a moth taped to a page. These bugs were simple. We could see them, we could find them. The failure mode became things like keep bugs out of a server room. It's gotten more complicated. But there is something that's interesting about this. I don't see any blame. No one tried to assign the moth the failure. I mean, the failure was because of the moth, but you can't blame a bug, right? That doesn't really work. And I don't see why we ever had to change that. No one on your team is ever going to want to make the site fail. They're never going to want a service problem or a bug in the code. That's never going to be their intention. It's better for the team this way. If we don't associate blame with the failure, we can learn from it. We can move forward and we can better ourselves. But blame tends to shut down the process. And because our systems have evolved, our post-mortem process is going to have to evolve also, along with these bugs. One way I want to look at post-mortems is sort of from an outside view. A lot of other communities have existed longer than software. In terms of industry, we're relatively young. So can we look at other industries that have existed longer than the software industry, learn from their processes to better adapt ourselves, to better learn from our failures? And the 2 industries we're going to look at have something in common. They handle life and death scenarios in the most literal sense. We all say this colloquially, but rarely when we're talking about our software do we actually mean those words. So with relatively high stakes, I think we can trust that they believe these processes are going to make things better for them because they have very high stakes. I think the first thing we need to look at is that every single mistake we make is an opportunity to better ourselves. It's not an opportunity to hold someone crucially accountable in a way that makes them feel bad, because we don't gain anything from that. I would say personally, I don't really feel much better in that even. I mean, you could make the argument that that's a reason to blame someone, but for many of us, we don't feel better by putting other people down. And when we start to shift from blaming to investigating, we can start to look at things like prevention, which is nearly impossible when you're blameful. So let's look at an older industry. There's an organization called the NTSB, the National Transportation Safety Board. They're tasked with keeping our transportation safe. And when I say transportation, I'm including rail, highways, aviations, shipping traffic by ships, pipelines, hazardous materials on our interstates. This is the group that ultimately makes advisements so that accidents don't repeat themselves. So there are some interesting things about the NTSB. They don't have prosecutorial authority. If we focus in just on aviation, we have things like the FBI and the FAA. They can prosecute. They have the ability to hold people legally accountable for their actions if they find them to be criminally negligent. But the NTSB doesn't have this. They exist purely to investigate a failure mode and make advisements of how to avoid it again. This allows them to have very honest and frank conversations. And that's because of a second rule that is going to allow them to, because they can't prosecute, people are very open. And as a result of this process, there have been 13,000 different safety recommendations made by this board. But let's try to tie this to something more concrete. So I have an example report from the NTSB. These are usually long, 10 to 20 pages, but I have a few samples that we can look at. Up on the screen is what you start with on any of these NTSB advisements. This one is about a shipping vessel and a fishing vessel. It seems pretty plain, pretty boring at first, right? We have a collision. We have some names of vessels. We have things like the weather that was involved, when it happened. And then there's a line here about cost. And in this case, there's only a monetary cost, but you also might have injuries or fatalities involved in an incident. So this, to me, resembles a lot of the processes I've had when we've had a failure and what a lot of executives want to know when something goes wrong with the service. It's about this level. And as you go further, you see things like photos and write-ups of this, documentation from different interviews and people and different experts of different areas. And in this case, it's a collision, and so there are some photos of what happened. So we can see that the shipping vessel was hit along its side by a fishing vessel, and we can see there was some damage, and so that's probably where the money came in. But more important than any of that is probably the very end. They address what the probable root cause of this was, and they lay out ways that they believe you could have prevented this from ever happening. So in this case, they believe that a better lookout system and earlier communication between vessels would have prevented this incident from ever happening. And these advisements go onto that list of 13,000 for all other transportation involved, so they hopefully don't repeat the same mistakes again. So I want to talk about another industry. The picture on the screen is a bit misleading. There's a thing called M&Ms, and I don't mean the Mars and Murray's candies like the shop down the road. I mean morbidity and mortality, a slightly more serious subject, as in the healthcare industry. You find that the healthcare industry and the transportation industry have shockingly similar goals, but there's a few nouns that change around. Ultimately, they care about providing better patient outcomes and better practitioners to treat patients. The interesting thing about morbidity and mortality is because of the volume of cases that happen in medicine, they don't look at every case. These conferences usually focus on more complicated issues when multiple agencies get involved, or it's a rare disease or combination of diseases interacting with each other, because that's how they can learn. It's not from your more direct case in your normal failures. So let's put some focus on the image on this slide. This is a fictional portrayal of one of these conferences. And when I look at this photo, I don't really feel like sharing much of anything. I feel that it's likely an adversarial relationship. These people are here to judge me, associate blame to me. They don't really care to learn from any of this. They're just hoping at the end of it, I'm at fault and they're not. And as long as that's the case, they're all right. Would it surprise anyone if I said that this is not really that accurate? Typically speaking, a morbidity and mortality conference takes place in something that looks far more educational, because that's the goal. It's in a lecture hall, or a setting where we feel like we can share and we can teach people from our failures. This previous example, which was animus and very, very negative, now has curiosity. which is going to net us a far closer result to what we would like to have happen. There's something interesting I found also during my research about medicine. A question kept coming up with, does it matter who's in the meeting? Is the content of the room going to change what we ultimately present? And it turns out this is rather split. About 50% of people surveyed believe managers should be in no way involved in this, and that the only people involved in the post-mortem process at a morbidity and mortality conference should be practitioners, with the idea being that only practitioners are going to learn from it, so really they should be the only ones contributing to it. But it's split, and so there's not a lot of strong signal there. But I found this really similar compared to tech. When I have these post-mortem processes in my workplace, I find that it's usually beneficial to have people out of the room if we tend to associate them as being blameful. And so it's not always management, but if you have someone in your team who you believe is toxic or keeps moving that environment into blame, it may be a good idea to remove them to get better results. And so that's what I took away from that. The other thing I found rather interesting is they often use a thing called the chairperson. So the idea here is it's very hard to present material to learn from and answer questions, as well as manage a meeting. We probably have seen similar things in technical meetings where we have someone take notes and someone else lead a meeting to kind of separate these things. And that's what they do in their post-mortem process. And this means you can focus on your question answering and the topic and not trying to balance who gets to speak. The other thing about this is it allows the other person to sort of protect you from those blameful people. So if it's noticed that someone isn't really trying to find better solutions in prevention and mitigation, that they don't get an audience to speak with. Curious if anyone in the audience recognizes this diagram. Has anyone used one of these before? It's called the fishbone diagram. It's pretty common within postmortem processes in tech in places I've worked. But I found that we didn't start it. This was originally used in medicine, and it tends to have labels that are a little different to us. We worry about patients and procedures. Oh no. Hey, there we go. We don't tend to worry about patients and procedures necessarily, but some of the other things are similar, right? We're going to worry about things like our environment. We're going to maybe worry about practitioners on our team and the other engineers and the processes we give them to follow. But this started in medicine. It's a way to get to a root cause. So we worry about an adverse event. So in medicine's case, a patient dying or an adverse reaction to a treatment. And we think about what things could have contributed to that. And that's very relatable to a bug failure. When we end up in an incident, if we walk backwards from the incident to the things we did along the way, we can likely find multiple contributing factors rather than just one. In our case, an example where we would say just one is, say, an engineer on the team failed. We don't learn why they failed, how the environment in some way let them down, what actions our users took, etc. So it's interesting to me that I learned a lot of these other industries before us use the same processes we use. I don't think we talk about that a lot. And I think we're letting ourselves down on the ability to reflect back upon it. I think what you'll ultimately learn from looking at other industries, if you take time on your own to do this, is that they've already figured out the mistakes or opportunities. A thing that I believe we better could embrace as an industry. I think they've learned that the only way that we can possibly work to fix our systems is through better preventative measures, which we're only going to learn if people feel open to share about their failures. And ultimately, we can't really fix people. We're humans, we make mistakes, but we can fix our processes and systems around us that we operate in to avoid future failure. Another interesting thing about postmortems that I particularly noticed with the NTSB is they're a great mechanism for providing historical context. If you don't write down how you fail, it's impossible to see patterns in the failure modes. But if you take good postmortem processes, you can reflect back upon what's happened in the past, and you can start to see patterns emerge and better prevent future incidents. So with all of this, how might we as technologists conduct a postmortem? Well, we need to search for a root cause and determine actions from reoccurring. And we're going to need a complete picture if we have any hope of fully understanding how to prevent things. I think we also need to worry about things like recency bias, which having historical context is going to help us with. And we need to see that most of our issues are not always one-off mistakes, but occasionally they're systemic. And having only a single perspective doesn't allow us to see the whole system. If we break down a post-mortem, we can do it into 3 steps. We ultimately care why this happened. We also care if it could have been worse or better, and we'll get into this more in a bit. And I think most importantly, we're worried about how can we make sure this never happens again, because that's the value we get from the post-mortem process. And the way we're going to do that is by focusing on things like action items at the end of a post-mortem, taking the actions to make sure these things don't happen again, and not focusing on the why and the who. So this is an example post-mortem. Processes will differ, but this one is very similar to one I use in my current workplace. We're going to start with a summary. It's not going to be highly technical usually. It's going to describe very simply what happened. So in this example, the documentation for the Google Cloud Python libraries, they were unavailable to the users. That's pretty simple. Management and your management's management is going to understand that. Great. We're then going to briefly describe the trigger or the root cause for the incident. And in this case, it turns out that this happened as a result of a repository cleanup within the system, and that an engineer had write access and was able to delete the GH pages branch of our GitHub repository, which took down the documentation. The actual failure is not necessarily that simple, but that's the best root cause we can give. And this is going to be good for people who are less involved in the process so they can understand the impact to the business. We're also going to worry about the user impact. Well, during a 2-hour period, the hosted reference documentation was unavailable. To my knowledge, this didn't cause any businesses to lose money, but it likely caused struggle for any developers using our services. And that's generally not good. So this isn't always about attributing a cost value, but you can have impact otherwise. And at about this point, where we move into detection, is where most management is going to stop reading. They care about the above things, but after this, it tends to get a little more technical. So we find that it took us a while to detect it. It was reported by an external customer. And we had about 30 minutes in time from the report to anyone on the team taking action. So that starts to give you an idea of sort of our response time for this particular incident. And then you talk about resolutions. Resolution can sometimes be very, very complicated. In the case of this issue, it wasn't. What was required is a republishing of the GitHub Pages branch. So this issue is unique in that it took longer to detect than resolve. And then, after this is where management really falls off. We tend to get more into timelines. When things happened, exactly how long they took. Occasionally, you'll bring up who did what action, have a better understanding of who has the context about this when it comes time to discuss this. So we have a brief timeline that lasted from 9:45 in the morning to 11:45. And we see the timings I said before. We had a branch that got deleted, took some time to be detected, team responded, the branch was republished, and we were serving docs again. I'm going to leave this for a second to reflect on those times. I said the times earlier, but there are definitely gaps in these, and none of them are smaller than 10 minutes. And for something as simple as a branch going away, I think that could probably be improved. Where we're going to get into that is in the next 3 categories, where we speak about what could have went well, what went poorly, and in ways we got lucky. We usually like to start with the positive, what went well. In the case about this, we were very fortunate that a customer noticed this rather quickly and filed a GitHub issue. They didn't move along and go get coffee. They told us. And from that, we were able to fix it. Without that, I don't know how long it would have taken. What went poorly is we didn't protect the branch at all from deletion. This is a very common feature that's used in GitHub, and for some reason, this repository, we'd missed that. When we configured it, we didn't think that we should protect the GitHub Pages branch. And so while it was published within 5 minutes, though, it also took us an hour before the docs were serving again. And it turns out we found that GitHub's logging and diagnostics for GitHub Pages sites wasn't very good. And our site was rather large. And so it took a while for everything to redeploy. And then you move into where you got lucky. And this is my favorite category, because this is how we take advantage of things that really didn't go well or poorly at all. They just kind of worked in your favor. And occasionally, well and lucky overlap. So I could have put the example in well into lucky as well. But I think where we really got lucky is the developer on the team had the branch local, and so we could push it. And had they not, it might have taken much longer to get this up and going again. This is arguably the most important section, though. This is how we gain any value from a post-mortem process. We take action to not only mitigate, but prevent future incidents. This is how we make sure we don't repeat ourselves. So we need to protect the GitHub Pages branch. We need to look into whether we can better debug GitHub Pages branches in the future. And perhaps we just need to be on GitHub Pages altogether. Maybe we're not really using this the way it was intended, and that's the problem. So someone after this is now going to have to spend time in the engineering cycle to make this happen. I want to repeat again that every individual on your team is acting with the best intention. They don't want to fail. No one likes failing. They didn't intend to do it. This phrase, we fail so we can learn, is what I hear internally when someone says fail fast. Because to me, fail fast, unfortunately, kind of implies that it's our goal. It's never the goal, but we should be willing to have it happen because we're going to learn that way. The other thing that I think is very important to remember is that blame isn't much of a deterrent. Punishing a team member isn't going to move you forward. It's also going to discourage transparency, and people are going to hide and downplay every issue they have. And anytime we excuse an issue as human failure, we can't learn from it. That's a stop point. Oh, they made a mistake. Why did they make that mistake? What processes weren't there to help them? So I want to look at a really quick example of why you might not want to blame. You get a customer issue that looks something like this. Some really bad thing happens in your site. The customer really doesn't know why, but it's bad, and they let you know. It was nice of them. And then some engineer on the team comes along and assigns it to themselves. Cool, all right, it's being worked on. The customer's probably happy, and then it's fixed. Cool. I have no idea why their computer caught fire. Presumably that engineer might have. Presumably that engineer had something to do with it catching fire. But I'm far more interested in knowing why that happened so we don't do it again than knowing it was fixed. And in a blameless system, this is all you're ever going to get. No one is ever going to let you know they made a mistake. So let's talk really quickly about why or how you would go about building a post-mortem culture. The first thing you need to do is think about psychological safety. And there are other talks at this conference that have talked about things like this in the workplace. But if you don't have this, it's nearly impossible to have a blameless culture. Psychological safety is what allows people on your team to feel welcome to make mistakes and that they belong. And if you don't do this, they're never going to feel open. I want to reference a chart that comes from an organization called Rework. This is another group at Google that publishes better management techniques that we've learned from as operating a big company in multiple spaces. And the first thing they talk about is psychological safety. And they believe everything else in a team is derived from it, whether someone can be depended on, whether the team can be well structured and people can communicate clearly, and ultimately whether you can have impact at all. And to me, blameless culture is directly related to having better impact and more action. Another thing you can do is find positive examples. I only picked one. There's a book that I've read called the Site Reliability Engineering Handbook, or just Site Reliability Engineering. It's written by some Google SREs, which is a discipline that spends most of their time worrying about these situations, the negative side of what we do. And in it, you'll find a lot of stories and anecdotes that they've experienced. And at minimum, this will help you be far more empathetic to that process and why we don't blame. Again, outages are going to happen, and no one wanted them to. We have postmortems so we can learn from them, not blame each other. So I wanted to run through a test for blamelessness. I think this first statement, a script is executed, that seems pretty normal to me in most postmortems. We attribute a computer to taking an action and causing a failure, which I think most of us in the room know is not true. In a slightly healthier culture, you might be able to say the phrase, an engineer executed a script that deleted the production database without confirmation. But if you're truly blameless, you can start to say things that sound like, Chris executed a script that deleted the production database. And this example is real. I did that. I did that last year. I was trying to clean up branches and do a helpful thing early in the morning, and I deleted the GitHub Pages branch without even thinking about it. So you might be saying to yourself that this doesn't seem relevant to me. My site works perfectly. I have some ideas for you too, if you somehow ended up in that case. There's an economist who liked to say, if you've never missed a flight, you're probably spending too much time in airports. Right? If you never fail, you probably have a healthy cushion. So you know what you can do? You can break your stuff. It's a lot of fun. It's a whole different talk, but look up chaos monkeys. Look at systems that try to ruin your day. It's a lot of fun. It's a great way to learn. The other thing to do is raise your SLA. If you're somehow hitting your SLA, make it higher. You will no longer be hitting your SLA, and you will have things to fix. So thanks, everyone.